Welcome to this section. You will learn how to work with getters, setters, and properties. First, let's start with getters and setters. Getters and setters are members of a class. Particularly, they are methods. What are methods? Well, methods are like functions that are associated to a specific object or a class. They are like the functionality that the object can perform. In particular, getters and setters let us get and set the value of an instance attribute. They serve as intermediaries. Getters let us get the value of an attribute, like their name implies, and setters set the value of an attribute. Both of them help us protect the attributes by providing an indirect way to access them and modify them. So they serve as intermediaries. We are not accessing the data or the attributes directly, but indirectly through these methods. If we define getters and setters, we can make the attributes non-public by adding a leading underscore, and still we can provide a way to work with them indirectly. So from outside of the class, we cannot access them directly, but through the getters and the setters. Let's see how getters work in Python. Getters should be named with this format. This is the typical naming convention that we use. First, we write the word get because we are going to get the value of an attribute. Then we write an underscore because we have to separate different words with an underscore. And then we just add the name of the attribute. And that is the basic format of the name of a getter. Right here we have some examples. Get name, get address, get color, get age, and get ID. These are all examples of getters for those specific attributes. Let's see an example in our code. Right here, we are going to define a movie class. And for that, we write the class header and the init method. In this class, we are going to add two instance attributes, title and rating. And they can be customized when you create the instance. But now, let's see how this is going to change when we write a getter for the class. Let's say that we want the title of the movie to be non-public. We just add a leading underscore to its name and we add a getter. How do we add a getter? Well, we just write the def keyword right here below init, indented, of course, so it belongs to the class, and we write the name of the getter, like for example, get title. Remember the format, the word get followed by an underscore and then the name of the attribute, title. Right here, within parentheses, we always have to write self, just like we wrote self right here as the first parameter in init. Then what are we going to get from the method? We are going to return the value of the title instance attribute. So as you can see, we're basically doing the same thing but through an intermediary. We are getting the value of this attribute and returning it when this method is called. Just like when we get a value from calling a function. Now, how can we get the attribute when we need to use it in our program? Well, to get the attribute, we just need to call the getter. And for that, we use dot notation again. Calling a method is very similar to calling a function, because we are executing or running its functionality. In this case, we will get the value of the attribute when we call the getter, and this is the basic syntax. First, we write the name of the variable that holds or references the object. Then we write a dot, followed by the name of the getter, which is get, an underscore, and the name of the attribute. And finally, we write an empty pair of parentheses, because getters do not take any arguments. Let's see how we can do this in our movie class to access the attribute. Great, so we've defined our getter in the class. It's time to create a movie instance. Let's call this my movie. We're going to create this instance and the title is going to be, let's say, The Godfather. Rating 4.8. After we have our instance, let's see what changes when we have to access that attribute, when we need to access the attribute in our program. We can use the instance, right? But now if we try to access the attribute directly, you will see this error. Unresolved attribute reference title for class movie. This means that the instance or the object doesn't have a title attribute. If we run the code, we see this error. Attribute error, movie object has no attribute title. This is because right now we are defining a getter for that attribute. So instead of writing the name of the attribute, we need to call the getter to get that value. We say my movie dot get title, and we write an empty pair of parentheses to tell the program that we want to run this functionality. We want to call this method, and getters don't take any arguments. They just return a value. Now, if we save the file and we run the code, we see the value right here, the Godfather. This is the output from this line that calls the getter for the title. We can use this anywhere we need to in our program. For example, we could write my favorite movie is right here, and we are using that call as an argument to the print function. You can replace this, of course, with your favorite movie and try to experiment with this example. You can see this. My favorite movie is The Godfather. We see this value right here, the value that was returned by calling the getter. Awesome, now you know how to work with getters. So let's start diving into setters, and we will do this in the next video. Now that you know how to work with getters, let's see how you can define and call setters in Python. Setters are basically methods that we can call to set the value of an instance attribute. And what is the advantage of defining setters and using them instead of just changing the value directly? Well, that with setters, we can validate the new value before actually assigning it to the attribute. So we can check if the value is appropriate for the attribute before we actually make the update, and we can avoid making invalid updates. This is a huge advantage of using setters in your class. Basically, setters follow this naming convention. We write the word set to specify that this is a setter, followed by an underscore and then the name of the attribute. For example, set name, set address, set color, set age, and set ID. Now take a moment to think about how you would define a setter in a dog class to set the name of a dog. Let's say that you want to be able to change the name of your pet. Try to do this, pause the video, and then come back so we can start writing the code. Welcome back. Let's start writing our dog class. We write the header and then we are going to write our init method. Great, so let's say that after a careful analysis, we considered that the name of a dog should be a non-public attribute. So we add a leading underscore to its name. First, we are going to define a getter. Let's have some additional practice defining getters right here. We see getName, self is the only parameter, and we return the attribute self.name with the underscore. Now we have our getter. But now we have to define our setter. As you can see, the syntax is very similar to the syntax that we use to define a getter. We use the def keyword followed by the name of the setter, which follows this format, set, followed by an underscore, and then the name of the attribute. Now within parentheses, we still have to include self, but we are going to add a new parameter, new name. Why? Because we need to know what name will be replacing the old name. We have to take an argument to know what name we are going to set. Great! In the body of the method, we can make all the validations that we need before actually setting the name. Let's say that we want to check if the new name is a string. Well, we can use this function right here, isInstance. This checks if the name is an instance of the class string, of the type string. And we can also check if the name is alphabetical, like this. We are using the string method isAlpha. Only if these two conditions are true, we are going to replace the old name. If that is the case, we assign this new value to the attribute. But if this is not the case, then we are not going to update the value, and we are going to print this message. Please enter a valid name. You could handle this alternative scenario, any way you like. You could print a message, you could do something with the attribute, you could assign a default value, anything that you like, okay? It's up to you to choose how to handle if the name is not valid or if the attribute is not valid. Great, in our class now we have our getter and our setter. So let's define a dog instance. We say my dog, this is going to be, my dog will be named Nora. We have the instance, so first we are going to confirm that my dog's name is Nora. So let's write my dog is, and we're going to write the name of the instance followed by a dog, and then we are going to call the getter. Why are we calling the getter? Well, because we need to get the name of this dog instance. And then let's say that we need to update the value of the name. We want to change the dog's name. We just call the setter like this. We write the name of the instance, the variable, then a dot, then the name of the setter, which is set name, and finally parentheses. But now we do have to pass a value right here. You can see that this part of the code turns yellow because it says parameter new name unfilled. We have to pass a value for this parameter in the setter, the new name. So we're going to change this from Nora to Norita. And after that, after we make that change, we can print the name of the dog again. But now let's customize the message. We say her new name is, and we call the getter again. Okay, so let's save the file and run our code to see what we get. We see this as the output. This is the output from this line of code. My dog is, at this point in the program, the dog's name was Nora, like we defined initially right here when we created the instance. On this line, we updated the name for the dog instance, and on this line, her new name is Norita. As you can see, the attribute was successfully changed. Awesome! But let's see what happens if this condition is not true. If the name is not valid and we do not update the attribute. Let's say that the name is not alphabetical. So for example, let's add this right here, a few numbers. If we save the file and we run the code, initially the dog's name was Nora, and we see a message that says, please enter a valid name. Then we see this message, her new name is Nora. The name was not updated, so the value of the attribute was protected by the intermediary, by the setter. We could also try to assign a value that is not a string and see what happens. Remember that we are also checking if the new name is a string. So let's see what we get. We save the file and we run the code, and right here we see this. My dog is Nora, please enter a valid name because the name was not valid, and the new name was Nora. It was not updated because this value was not valid. So you can see the amazing power of setters. They help us protect the attributes by providing an indirect way to change or update their values and access their values. Awesome! Now you know how to work with getters and setters. Welcome to this practical coding session. Now we will start diving into two examples of classes where we will define getters and setters. Let's start with our backpack class, and let's define our init method. We will have our initially empty list of items. In this case, we're going to make the items attribute non-public, or sort of like protected. And for that, to provide access to that value and to be able to update the value, we will have to define a getter and a setter. To define a getter, we first write the def keyword indented. Remember that this should be indented at the same level for them to belong to the class definition. Then we write the name of the getter, get, followed by an underscore, and then items, which is the name of the attribute. And within parentheses, we write self. What are we going to do? We are going to return the value of the items attribute. We write self, dot, and items with a leading underscore, like we have right here. This way, we are providing an indirect way to access the attribute. And we also want to be able to update update the attribute. So we are going to define a setter. Set underscore items. This is the basic format of a setter, but we also need to add something right here. We need to define a second parameter because we need to know or get the new value that will be assigned to the attribute. And we take that usually as an argument. So we have the new list of items. And what are we going to check? The items attribute is a list, so that should be preserved. We're going to check if the new items value that was passed as an argument is of type list. If that is the case, then we are going to assume that it is valid in this case, so we can replace the old value of the attribute. But if that is not the case, we will tell the user, please enter a valid list of items. And there you go. We have our getter and our setter defined for the items attribute. Great, so let's see how this works by creating a backpack instance. We say backpack, we create the backpack, and what are we going to do? Well, we are going to print the initial list of items through the getter. We are going to call the getter to get the list of items when we create that instance. Let's save the file and run the code. We see an empty list, which is exactly what we expected, the initial value. After we have that, let's call the setter. Let's update the value of the items list to a new list. Let's say that we have, for example, we want to have a water bottle, a sleeping bag, and a first aid kit. This will be our new list of items. So let's use a print statement right here and the getter again to print the list of items after this update. Right here we can see this. Initially we have an empty list, and after the change, the items attribute is updated to this new list, the argument that we passed to the setter. Great! Now let's see what happens if the argument is not valid. For example, if we write right here instead of a list, a string or something like that, a value of a different data type. Let's see this. First, we have an empty list. We see the message, please enter a valid list of items, and then we see the empty list again right here. The value was not updated. So we protected the integrity of the data, of the state of the object. And that is one of the main advantages of using getters and setters as intermediaries to update and get a value. Great, so now let's go to our second example. We're going to define a circle class. And in that class, we're going to define our init method. This time, we're going to take the radius of the circle as an argument when we create the instances, and we are going to make this attribute non-public. For this attribute, we're also going to define a getter and a setter. Try to do this. Try to define the getter and the setter for the radius attribute. In the setter, you need to check if the radius is of type float. Let's say that we want to represent the radius as a float, so we want to check if it is a float and if it is greater than 0. These are the validations that you need to implement in your setter. Think about this for a moment, pause the video, try to write the code, and then come back to complete our class. Welcome back. First, we need to define the getter. We write def, getRadius, self, and we are going to return the value of the radius attribute with a leading underscore right here. Now we have our getter. Our setter has a few more details that we need to implement. First, we need to get the new radius as an argument when we call the setter. And we need to check if the new radius is an instance of float, if it is of type float, and if it is greater than 0. Remember that we are not going to take values equal to 0 or negative. If that is the case, if all these conditions are true, then we can update the value of the radius. But if that is not the case, we can say, please enter a valid value for the radius. You can customize this message to your liking. Great, so now we have our circle class with a getter and a setter. Great work! let's see how this works by creating an instance. Try to do this yourself. Create an instance, then call the getter, call the setter to update the value, and then check if the value was updated. Pause the video for a moment, try to write this in your code, and then come back so we can do this together. Welcome back. Now we're going to create a circle instance. So in this case, since we're expecting a float for the radius, I am going to pass the value 5.0. Okay? So we can confirm if the value of the radius is actually 5.0 by calling the getRadius getter. And we can see 5.0 right here as the output, so it is. After this, we can change the value of the radius by calling setRadius. In this case, we are going to change the value of the radius to 10.5. And then we are going to call the getter again to confirm that this change was successful. Now, if we save the file and we run the code, we see this. Previously, the radius was 5.0 and now it is 10.5. Awesome. But what happens if we pass a value that is not valid? For example, the radius has to be greater than 0. If we pass a radius that is equal to 0, we will see this message. Previously, it was 5.0 right here, and then we see this warning message. Please enter a valid value for the radius. And after that, we see that the radius was not updated because this condition was false. The radius was not greater than 0. And we could also try to update the radius with an invalid value like this one with a string. What do we see? Well, we see that the attribute is not updated, exactly what we needed. We see please enter a valid value for the radius. This time, this part of the condition was false. The radius was not a float. Great, so now you know how getters and setters work, and you had some practice with these examples, defining them and calling them in your programs. When you're ready, go to the next video so you can start learning the Pythonic way of working with getters and setters. You will commonly see getters and setters in programming languages like Java, but in Python we use something called properties. You will learn more about them in the coming video, so I'll see you there. Now that you know how to work with getters and setters, let's start diving into properties in Python. Getters and setters are very commonly used in object-oriented programming because they help us follow and implement the principle of encapsulation, showing only the attributes that we want to show to the outside world. But in Python, we typically don't work with getters and setters, at least not directly, because we have a better alternative. Let's see why. If we have a very simple dog class with an age attribute that we have used in many different parts of our program or project, and then, after writing the program, we are asked to validate the age before assigning it to the attribute, then based on what you have learned so far, we would have to make the attribute non-public by adding a leading underscore, and then define a getter and a setter for that attribute, right? This is what you have been learning so far. In that case, the class would be similar to this that we have right here. We have the init method, we have the getter, and we have the setter that checks if the age is an integer and if it's greater than 0 and less than 30. The problem is that we already use the traditional syntax to access and update the attributes in our program. Like this, we are accessing the attribute with dot notation and we are updating the attribute using a typical assignment statement with the dot notation right here. So this will throw an error everywhere that we use this syntax. If we do this, if we change this to non-public and we add getters and setters, we would need to replace all of these lines of code in our program by calls to the getter and to the setter. And that would not be practical or realistic if we are working with a large and more complex project. We have a better alternative. First, let's start by writing the class and seeing the effect that this change has in our code. Let's define our dog class right here with an init method and the age attribute. We have our class and now we are going to create our dog instance. We have to specify the age of the dog. So we're going to use some attributes of the dog in our program, and we are also going to update its value. We say my dog is, we are going to access the age of the dog directly using dot notation, years old. And 1 year later, we are going to update the age by incrementing it by 1 directly, and then we say, my dog is now years old. Okay? We are accessing this value twice using dot notation, and we are also updating the value. But what happens if we are suddenly asked to validate the age? In that case, according to what you have learned so far, we should add a leading underscore and define a getter and a setter. So let's do that. Get age, return self.age, and then set age. And we write here new age, self.age equals new age, but now we have to validate the age. Let's check if the new age is an instance of int, if it is an integer, and if the age is between 0 and 30. Let's say that this is a criteria that we were asked to implement in our code. If this is the case, then we update the attribute. If this is not the case, then we have to print a descriptive message. Please enter a valid age, like this. So now we have our getter and our setter and our non-public attribute. Awesome. So initially you might think that this solves the problem. Now we are validating the age. But the problem is what happens with the code that we already wrote in our project. Right here, the code that is not part of the class. The class was modified. But right here, we are using the age attribute in several places in our code. And right here we are seeing them in yellow, highlighted in yellow, because now the dog object doesn't have an age attribute. Remember that we made this attribute non-public, and now we can only access it by calling the getter. We would have to replace right here, everywhere where we access the age attribute, we would have to replace this by a call to the getter. And where we update the attribute, we would have to replace it by a call to the setter. In this case, it might seem simple enough, because we only have to make 3 small changes. But imagine if this happens in a large project with thousands of lines of code. We will have to change this in every single place in our code where we access or modify the attribute, and that is simply not practical. But before you panic, let me tell you that we have a really awesome solution for this in Python. They are called properties. We can define a property in the class using the property function. We just need to specify the getter and the setter that we want to assign for that particular property, and assign the result or the object returned to a particular variable right here, which will be the property name, this right here. Let's do that in our code so we can add this property and see the effect that it has on our code. To solve this problem, we just need to create a property in the class. Let's see how you can do that. We have our class with a getter and a setter. So right here, after the getter and the setter, we can define the actual property that we want to create. We want to be able to access this attribute with the same name, age. So we're going to define the age property right here. And as arguments, we need to pass the name of the getter and the name of the setter. We write getAge and setAge. Now we are connecting this property to these 2 methods, the getter and the setter. We have to specify them in this order, okay? Now, if we see the code that we wrote previously before we added the getters and the setters, we can see that the yellow warnings disappeared, because now the dog object has an age property right here. If we hover over the name, we can see this, property age of main dog, okay? We can access and modify the attribute with the same syntax, but now we have the getter and the setter acting as intermediaries. Now everything is working correctly. When we define a property in Python, we can use the same syntax to access and modify the attributes, just as if they were public, but we are still using the intermediaries, the getters and the setters. The getter and the setter will be called behind the scenes, for the corresponding operation. For example, when we try to access the attribute using dot notation, the getter will be called. And when we try to update the value of the attribute, the setter will be called. Let's see this in our code, and let's use print statements to confirm that they are actually called behind the scenes. And we say, calling the getter, and then we can say right here, calling the setter. And these print statements will run whenever we call these methods. Let's save the file and run our code and see the output. Let's analyze the output line by line. We say calling the getter because right here we have to access the age attribute of the dog instance before we actually print this message. My dog is 8 years old. This value has to be retrieved or known before printing the message. Then we print 1 year later, and we are calling right here the getter again, and the setter, and the getter. Why? Right here, we have to get the value of the object, so we can update it. Right here, remember that this is equivalent to doing this. My dog.age plus 1. So first, we have to get the attribute, the value of the attribute by calling the getter. Then, since we are updating it, with this assignment statement, we have to call the setter, and then right here for this message, we have to call the getter again to print the final message. My dog is now 9 years old. You can see that the value was successfully updated. This is just a more concise syntax. So this confirms that we are actually calling the getter and the setter behind the scenes, when we use the same syntax that we used when the attribute was public. Awesome! Now you know how to work with properties in Python, using the property function. Welcome to this practical coding session where we will define properties in our circle class, so let's get started. First, we have to define our circle class, and now we are going to define two instance attributes, radius and color. But in this case, these two instance attributes will be non-public. So we are going to add a leading underscore. First, let's start with the radius. We are going to create a property for the radius. So for that, we need to define a getter and a setter for that particular attribute. We say getRadius with only self as the argument, and for that, we have to return the radius. So we have the getter. Now let's define the setter. We're going to take the new radius as an argument, and we are going to check if the new radius is greater than 0, then we are going to accept it. Okay? Alrighty, let's say that we're only going to take integer values for the radius. So we could assume that it is an integer, or we could check if it is an integer in our condition as well, okay? If that is not the case, then we just print the message, please enter a valid radius. Awesome, so now we have our getter and our setter for the radius. How do we define the property? Try to define the property right here. The property's name will be radius. Try to complete this line of code with the property. Pause the video for a moment, write this line, and then come back. To write this line of code, we just need to call the property function, passing the name of the getter as the first argument and then the name of the setter, like this. And voila! Right here we will have a property named radius. So we can use the same syntax that we used before to access the radius attribute. And we will have the benefits of these two intermediaries to protect the data and the value of the attribute. All of this code was written to protect the radius attribute. But now we also want to create a property for the color. And how can we do that? Well, right here below this property, we will have to define a getter for the color, like this. And then we have to define the setter for the color. And we take the new color as the argument. But in this case, we're going to do something a little bit different to check if the color is valid. We want to check if the new color is in a list of valid colors. And where can we find that list? Well, we're going to define a class constant. A class constant is just like a class attribute, but we use a naming convention of writing the name in uppercase letters to specify that we don't want to change that value, that the value should be treated as a constant, because Python doesn't really implement constants. We use this naming convention of writing the name in uppercase letters to tell other developers that this should be treated as a constant. So we're defining this constant as a tuple to protect these values even further. Tuples are immutable, so they cannot be changed. And we specify the 3 valid colors for the circle: red, blue, and green. What are we going to do right here in the setter? We're going to check if the new color that was passed as the argument is in the list of valid colors. So we write circle.validColors. This is a class constant, a class attribute, a class member, so we can use the name of the class dot the name of the attribute. If that is true, if that is the case, then we are going to update the color with the new color. But if that is not the case, then we just print, please enter a valid color. And we don't update the color. Awesome, so now we have our getter and our setter, and it's time to define the property. The property will be named color. Just like the attribute, this is very common, and you should usually name your property the same as the attribute that you're trying to protect or shield from the outside world. Try to complete this line right here. Define the property with the getter and the setter. Pause the video and then come back. Welcome back. To define the property, we use the property function and we pass the name of the getter and the name of the setter right here. And we will have our color property defined. Awesome, now we have our class with 2 properties, a radius property with the getter and the setter, and a color property with the getter and the setter. So let's go to our main program, and we say, my circle, we're going to create a circle instance with a radius of 10 and color blue. Right here, okay, radius and color. And blue is one of the valid colors. So let's see what happens with the radius. We're going to first print the radius to check if it was assigned correctly. Let's save the file and run the code. And we see the value 10 right here for the radius, which is correct. After that, let's say that we want to update the value of radius to 16. Right here, we are calling the getter, and right here on this line, we will be calling the setter. If the setter was called appropriately, then the radius should be updated correctly. We save the file and we run the code and we see that the value was updated. From 10 right here, it is 16 right here. And if we try to update it to an invalid value, we just see this message, please enter a valid radius, and the attribute is not updated, so it is being protected by the setter. Great, so now let's test this with the color. So we say myCircle.color, and then let's say that we want to update the color to red. Previously it was blue, we want to change it to red, which is one of the valid colors. And then let's check the color after this change. First, let's comment these lines of code. Let's comment them out so we can see just the output for these 3 lines of code. And we see blue and red. The color was updated successfully. Previously, it was blue, and now it is red. If we try to assign a color that is not in the list of valid colors, like for example white, then let's see what happens. We see blue, please enter a valid color, and then blue. The color was not updated because this was not a valid color. It was not in the list that we defined right here as a class constant. The add property decorator is really amazing. We get the same functionality that we got when we used the property function, but with a much more concise syntax. We just need to write add property, and a special process will start behind the scenes. Let's see this in detail. First of all, what is a decorator? A decorator is basically a function that takes a function as an argument and extends its behavior without explicitly modifying it. That is why we call it decorator. It is sort of like decorating another function by extending its behavior. but it doesn't explicitly modify the function, it just adds some extra flavor or functionality to the function. The new syntax that you are going to learn right now using the add property decorator is cleaner and it is more compact. So we typically use it in Python. We avoid working with getters, setters, and with the property function whenever possible. We use this syntax that you're going to learn. It is also easier to read and understand, and it avoids calling the property function directly. We will also reuse the name of the property if we use the add property decorator. So we avoid adding new names like the name of the getter and the name of the setter to our list of valid names in the class. This is basically how you can define a getter using add property. You can see add property right here at the top. First, you write add property, and then you basically use the same syntax that you would use to define a getter. We have the def keyword followed by the name of the property that you want to create. Right here, instead of writing get and the name of the attribute, we are just writing directly the name of the property. If we have, for example, an age property, this would be age. If we have price, this would be price, and so on. Then we have self as the only parameter, because this is a getter. And in the body of the method, we have a return statement that returns the actual attribute. Usually that attribute will have the same name as the property that we write right here, just with a leading underscore, because it is non-public. Let's see this with an example. Right here, we are going to define a movie class, and we are going to define right here the init method with two instance attributes, title and rating. We're going to keep this class simple so we can focus on the syntax of add property. We define these two instance attributes, title and rating. And let's say that we want to make the rating be a non-public attribute, like this. So how can we use the add property decorator to define a getter and a setter for the rating? We just write add property right here, and then we start writing our getter. Instead of writing get rating, we will just write rating, the name of the property that we want to create. And in the body of the getter, we will just write what we usually write in a getter, return the attribute. The main changes are this right here that we have to add before the first line of the getter, and that the name of the getter is the name of the property, not a name that we create like get rating. Okay, so now we have our getter. Let's test that the getter actually works like we expected by creating an instance right here. Let's say favorite movie, and the title will be Titanic with a rating of 4.3. To test if the getter is working correctly behind the scenes for the rating property, we just need to access the rating of the favorite movie instance. To check that this is actually being called behind the scenes, we can also add a print statement and print calling the getter. So let's save the file and run the code. And right here we see exactly that. We see the message that we print right here, calling the getter. So in this line, when we try to access the rating, we are actually calling this behind the scenes. We see this message calling the getter and we get the rating and print it on this line right here. We can also define a setter with the add property decorator, like this. We just need to write add, followed by the name of the property that we use, the property that we created with a getter. Remember that previously we were writing a getter. That is the name of the property that we created. Then we use that name, we write a dot, and then the word setter. This tells the program that this is the setter for this particular property. And then we use the same syntax that we would typically use to write a setter. The def keyword followed by the name of the property. Right here, instead of writing set and the name of the attribute, we are just writing the name of the property directly. And in the list of parameters, we have self and the new value that we are going to take as argument. In the body of the method, we see the same assignment statement that we would typically see in a setter. And we could also implement code to validate the value before assigning it, to check if it's valid, and to handle cases where it is not valid. Let's see this and how we can write a setter using this syntax with an example in our code. Our getter is working correctly, so now let's define a setter for the rating. How can we do that? We usually write the setter below the getter, so let's do that. Let me zoom in so you can see all the details, because setters do have some small changes. We have to write an @ symbol and then the name of the property for which we are creating the setter. In this case, the property is named rating, so we write rating right here, followed by a dot, and then the word setter. Great! After that, we just write what we would usually write for a setter. The only change is that instead of writing set rating, we just write the name of the property for both the getter and the setter. These decorators are telling the program which one is the getter and which one is the setter. And right here, since this is a setter, we need to take a value, the new rating, that we are going to set. And what are we going to do right here? We are going to check if the new rating is greater than or equal to 1.0 and less than or equal to 5.0. If this is the case, then we can update the rating with the new rating. But if this is not the case, then we can print the message. Please enter a valid rating. We could also check if the new rating, is an instance of float. So we're basically implementing the functionality that we implemented in a setter, but we are using right here a different syntax to define the header. Let's see how this works, and let's check that this is actually being called behind the scenes with a print statement. We say calling the setter, and let's try to update this right here. We say favorite movie dot rating, and let's change this to 4.5. After that, we are going to check if the rating was updated successfully. Let's save the file and run the code. And right here we see this. We are calling the getter, and then we print the rating, 4.3. After that, we have to update the value. We call the setter because we are updating the value to 4.5. This assignment or update of the value is calling this method behind the scenes. And right here, finally, we are calling the getter again, and we are printing the rating, 4.5, which was updated correctly. Now let's say that we want to change the rating to an invalid value. We have a bug or something that is not correct in our program, and it tries to update the rating to a negative value. Let's see what happens. You can see that the rating is not valid. We say calling the getter, 4.3, calling the setter, please enter a valid rating because this one is not valid. And then when we call the getter again, we see 4.3. So the rating was not updated. It was protected by the setter that we have right here. Awesome, now you know how to define a getter and a setter using the syntax add property and then add the name of the property dot setter. Remember that you don't use the names get rating and set rating. You just use the name of the property that you want to create, and you will be able to use the same syntax that you use outside of the class. Awesome work! When you're ready, go to the next video. I will see you there. Welcome to this coding session. In this example, you're going to practice how to define a getter and a setter with the add property syntax. Let's start by defining our backpack class. And right here we have our init method and our initially empty list of items. Now, based on what you've learned, try to write a getter and a setter using add property for the items attribute. Pause the video for a moment. Try to write this yourself in the code, and then come back. Remember that you have to check if the list of items is actually a list in the setter. Welcome back. First, let's start writing the getter. And for that, we need to write add property before the header. Then we have to start writing the method. We use the def keyword and then the name of the actual property that we want to create. This is the same name as the non-public attribute, usually. And then we are going to write the same line of code that we would write for a getter, which is returning the value of the attribute. Now we have our getter. Great work. So let's start writing our setter. For the setter, you have to write the name of the property, which is items. And then you have to write the word setter. the name of the property, dot setter. After that, you write the first line of the setter, but the name is the name of the property. You reuse the name of the property for both the getter and the setter. Okay? We also have to take the new list of items as an argument, and we check. If new items is a list, then we can make the update. Awesome. If it's not a list, then we just print, please enter a valid list of items. Great, so now we have our getter and our setter. And notice how this syntax is much more concise than when we use the property function. Let's create a backpack instance right here below. And let's check that they're actually working like getters and setters. We say my backpack.items. Remember that we can use the same syntax that we used before. Dot the name of the property. And the getter and the setter will act behind the scenes. We're going to get the value of the items, and then we are going to update that list. We're going to include a water bottle and a sleeping bag, like this. And then we are going to print the list of items to check if it was updated successfully. But before we do that, before we actually run the code, let's add print statements to confirm if the getter and the setter are being called. We say calling the getter, and right here we write calling the setter. Okay? We save the file, we run the code, and right here we see this. Calling the getter, we see the empty list of items right here. We call the getter because right here we are getting the value of the items property. Then we are calling the setter because we are updating that value with the setter. And then we are calling the getter again to print the updated value. This one right here, water bottle and sleeping bag, are the two items that are now in our list of items in the backpack. Great, so let's see what happens if we try to assign an invalid value for the list of items. We see that the value is not updated. We just see a warning, please enter a valid list of items, and the value is protected. Great, now you know how to work with add property in Python. And you can define a getter and a setter for your property and use the same syntax that you use outside of the class. Great work so far during the course!